So now that we've looked at ionic compounds, we're going to take a look at a couple different types of ionic compounds that don't follow the same basic rules. First, we've got the transition metals, okay? The transition metals, remember, are in the middle of the periodic table. Right here are the transition metals, technically speaking. But when we talk about these rules, we talk about the transition metals and some more of them over here. That's why I like to say that we talk about the transition metals and some others. So there are three transition metals that only have one possible charge. But for the rest of the transition metals, we're going to use Roman numerals in the name. So, for example, if we have iron, Fe, and iron has a positive 3 charge, the name of iron 3 is going to be iron 3. But silver here, for example, is not going to be silver 1. It's just going to be named silver. So I like this table because this table really summarizes everything. It has all of the ions that do not need Roman numerals, right? First of all, obviously the negative ions don't need Roman numerals. Our negative ions would never need Roman numerals. Next thing, here is the alkali and the alkaline earth metals, and they do not need Roman numerals. These are the ones that we've been using all along. So, for example, the name of this one is calcium. All right, we don't call it calcium 2. All right, we just call it calcium. And then I told you about these other three exceptions here: cadmium, silver, and zinc. And then in this positive 3 charge area, aluminum and gallium also do not need Roman numerals. Um, the next thing I want to tell you about are the polyatomic ions. All right, the polyatomics are poly, many, atomic, atom, many atom ions, okay? So they're clusters of atoms that have an overall charge. The easiest, or the first one we kind of learn about, is the hydroxide ion, or OH, with a -1 charge. The second one is the nitrate ion, and there are many, many more after that. On your periodic table, if you go to the next page or if you flip it over, whatever you have, there is a section called the common polyatomic ions. And you'll notice I have them listed here with -1 charge, a -2 charge, and a -3 charge. Most of the polyatomics that we talk about have a negative charge. There's only one positive polyatomic ion that I have there. There are more past this list, but these are the ones that we use in Chem 1 the most. Now, I want to point out to you, polyatomic ions have endings like 8 and um, 8 and ite, right? So there's ites and eights and eights and ites. There really is only one ide, which is the ending that we've been using so far, and that's cyanide, which is not from the periodic table. So when you see nitrate instead of nitride or nitrite instead of nitride, we're probably going to be looking at a polyatomic ion. So these polyatomic ions, just like other ions, are attracted to oppositely charged ions and they form compounds. When using the polyatomics in compounds, never alter their formulas. So for example, NO3 has a +1 charge. If it gets together with magnesium, which has a +2 charge, we know we're going to need 2 NO3s to cancel out 1 magnesium, or you can think of crisscrossing here. We're going to need 2 of these puzzle pieces for one of those. We do not alter the formula, okay? This is the way we write it. We write an NO3 in parentheses, and then we write a 2 after it. This is all you can write, so you can't write N2O6. I know a lot of people, when they start chemistry, think you're going to be able to do that. If more than one are needed, we're going to use those parentheses around followed by the subscripts like I just showed you there. Additionally, don't forget, one of everyone's favorite one to forget is this guy right here, OH with a -1 charge. That's hydroxide. If hydroxide gets together with, say, calcium, which has a +2 charge, okay, if you think of the crisscrossing, if you like to think about that, you get calcium hydroxide, and you still have to use those parentheses, and you still need to make sure your 2 is on the outside of the parentheses. Polyatomic ions come in, they have -1 charges, -2 charges, and -3 charges. The only one that we talk about that's a positive charge, like I said, is ammonium. These charges really don't have anything to do with the number of oxygens present, okay? So don't let that confuse you. You may have 4 oxygens and a -1 charge, or 4 oxygens and a -2 charge. Here are some examples. We've got sodium with a +1 charge and nitrate. You need 1 of each to cancel. So you get NaNO3. And again, this is named sodium. And this is nitrate. And if you put nitride, that would be wrong. The next one is potassium, has a +1 charge, and this is sulfate with a -2 charge. Now, the only reason that I know this offhand is because I have these memorized and have so for a really long time. You don't yet, so you're going to need to use the back of your periodic table. And this last one is calcium, all right, and that's ClO3. And like I said, if you don't know what that is, you need to go to the back of the periodic table or go to your notes, find ClO3. There she is, and that's chlorate with a -1 charge. So the name of this one right here, sorry, is calcium chlorate. And notice there's the 2 after the parentheses there. Now, I gave you this list of polyatomic ions. I need you to memorize this list. There is a quiz never. Okay, so it's we're not going to be able to give a quiz on that, and I'm sorry for your loss, but normally I would. So you don't need to worry about any of this or worry about any of this. Just know that usually chemistry students do memorize the polyatomics, so it's not a bad idea to start committing those to memory.